Okay, here we are, last section of Chapter 2, and this is 2.5. So far, after we made the graphs of data, we went to measures of central tendency, mean, median, and mode. What's one number to describe the set? Then we just finished with measures of variation, how spread out the data are. And the last thing we want to talk about are measures of position. Where is one value in relation to the rest of the set? So this is measures of position. And we'll be talking where a single data value is in relation to all others. Okay. These are called fractals. And what a fractal does, fractals are the values that divide an ordered set, so smallest to largest, into approximately equal parts. So there are two common fractals used in statistics, and the two are called quartiles and percentiles. We're going to spend most of the day talking about quartiles. So quartiles, as the name suggests, are the values that divide a data set up into about 4 equal parts. So divide a set into 4 approximately equal parts. So how many quartiles are there? So again, the quartiles are the values that divide the data set into 4 equal parts. So think about a board. How many times would you have to cut the board to get 4 equal chunks? So how many times with your saw would you cut? You would be cutting 3 times. So you would cut the board in half. Then you would take each of those halves and cut, so that you had 25% here, 25% here, 25% in each of those. So this first cut is called quartile 1. It separates the bottom 25% of your set from the upper 75. Quartile 2, 50% below, 50% above, and then quartile 3, 75% below and 25% above. So there are 3 quartile values, quartile 1, quartile 2, and quartile 3. Well, if you think about it, quartile 2 is the middle data value. It's the one that cuts the set in half. The quartile 2 is our median that we've been talking about. So quartile 2 and median are the same thing. So let's practice quartiles. So let's say first test, 13 test scores. And I'm going to go lowest to highest. I'm going to give them to you. So just listen and write them down. Don't just bob your head up and down here. Lowest score was 40%, 68, 70, 72, 88, 88, 89, 90, 93, 94, 94, 98, 99. Okay, there are 13 scores here, and I'm going to ask you to find the 3 quartile values. Well, you can do it by hand when it's this small, so we'll spend time doing this one by hand, and then I'll show you the 1-bar stats, which will give us the same values. So because there's 13 values, we want the middle one, so you can count your way in or whatever technique you want to use. Working my way into the middle. So 89 is our middle value. That's our quartile 2. That's our median. So what we say is about 50% of the data is at or below. And I say about because you can see if you include it down here, this side is 1 bigger than this side. So that's why they are approximately 4 equal parts, because of the odd value. You can be 1 off from being perfect. So now what you do to find quartile 1 is you take this bottom chunk here, not including that quartile 2, and you want to find the middle of this chunk. Well, there's 6 values in here, so you're going to have to average like we did before for median. So the middle, it's going to be the middle of these two. So if you average 70 and 72, 71 will be quartile 1. So about 25% of your values are at or below 71. We don't have a 71, so exactly 3 are below. And then to find quartile 3, you take this upper half, not including quartile 2, and you find the middle here, and it will be the average of these two, which is a 94. So about 75% of your scores are at or below 94. And you can see that about because it's being included in both this quartile and this quartile here. Okay, could we have gotten those off of the calculator? Absolutely. I have them in list 1. I showed you this yesterday. If you stat, calc, 1var stat, L1, remember the quartiles are there. If you arrow down, quartile 1, 71, just what we had. Median is quartile 2, so we've got to know that, 89. Quartile 3, 94. So that's all built in. Kind of nice. So the quartiles can be found under 1var stats. You want Q1, median, and Q3. Alright, we want to talk inner quartile range. Okay. Interquartile range. It's the range of the middle 50% of your data. So really it's just the difference between Q3 subtract Q1, that distance. Its purpose is that it helps identify outliers. Remember the values that are way far removed from the rest? And I said there would be a formula to help us decide if something's far enough away to be considered an outlier. Well, here's your 3 steps. You first take that inner quartile range, Q3 minus Q1, multiply that by 1.5. I'm going to call that result V for some value. Now what you're going to do is go take your Q1 value, Q1, and subtract this answer, this value here. We'll call that our L for our lowest end. Then take your Q3 value and add this V to it. It's going to give us a number on the high end. And what happens is if we have any data values that are lower than this low or higher than this high, those are considered outliers. So what it is if they're more than 1.5 times the inner quartile range away from the low and the quartiles, then they are considered outliers. So I'll say that here. If any data value is lower than L or higher than H, it is considered an outlier. So if we look at that first example again, I did give one low value in here, this 40. Yeah, it's a lot lower than this chunk here because these are pretty consistent through here. Would 40 be considered an outlier for this problem? Well, let's go through those 3 steps and see. So, we'll make that our next example. Is the 40 from example 1 an outlier? So, we're going to take our Q3 minus Q1, get those values back in here. So we've got 94 minus 71. Multiply that by 1.5. (94 minus 71 times 1.5), 34.5. Okay, so that's my V in my formula I gave you above, or in my steps above. Now I'm going to take Q1 and subtract that V. My Q1 is 71. Subtracting 34.5. 71 minus that last answer, 36.5. So, because 40 is not lower than 36.5, anything below 36.5 would be an outlier. 40 is not below, so 40 is not an outlier. And the last thing we're going to do with the quartiles is make a box and whisker. And I think you made these probably back in junior high. But the box and whisker plot is also a very common statistical graph to give. And this is a graph based on quartiles. And the key characteristics is that you box in the middle 50%. Top and bottom 25%. Are whiskers. So you need 5 values to make a box and whisker. You need your max and min, and the 3 quartiles. So if we make a box and whisker of example 1, if you remember, box and whiskers are made above a number line. So our minimum value, our minimum test score was 40. Our max was a 99. And our quartiles were 71, 89, and 94. So we need a number line that goes from 40 to 94. So I think I'll just go 40 to 100 and count by 5. 45, 50, 60, 65, 70, 75, 80, 85, 90, 95, 100. Okay, so if you mark your 5 values, 40, 99, 71, 89, and 94. Okay, remember the middle 50% are the box, so that's from quartile 1 to quartile 3. So what that's showing is 50% of your data values are in here. We do mark quartile 2 with a bar, so there are as many test scores here as there are in here. Remember, it's how many values are in each chunk. The whisker, you remember, looks like this, and then the bottom whisker. Again, these chunks just representing how many data values are in here. You can see that these are more spread out. There's just as many data values here as there are here. So that's our box and whisker. Okay, again, you can make a box and whisker on the calculator very easily. And the way to do that, you enter values into the list. You're going to go to stat plot. You're going to select box and whisker. And then you're going to go back out and have the window all set up by going under Zoom and selecting Stat. So, there you go. So this is the one where I have my values in the list. My test scores are there in list 1, so I'm going to quit. Stat plot, remember, is above the y equals. Number 1, I'm going to turn it on. I can see the box and whisker here. Well, there's 2 box and whiskers. This one will show you outliers. This one includes the outliers as part of the data set and doesn't separate them. So it doesn't matter which one I pick because they're going to look the same because I didn't have an outlier. List 1. Frequency is going to stay 1. Now I'm going to go to Zoom. Look for stat. I believe it's down at 9. Enter, and there it is. Now if I hit trace, which is along this top row here, I can start at the median, and if I just go left and right, it gives me all of the key values that it took to make it out of the 5 key values. So, calculators make them, programs make them. Alright, so I spent a lot of time on quartiles, and then the other common fractal that's used are percentiles. When you take your SAT and you get your score back, they're going to tell you what percentile you were in. So if we think percentiles, if quartiles divided a group up into 4 equal parts, percentiles divide the data set into 100 approximately equal parts. So we've got P1, first percentile, P2, all the way through the 99th percentile. Okay, and if you think about it, there's going to be overlap between percentiles and quartiles. Quartile 1, separating the bottom 25% from the upper 75, is going to equal the 25th percentile. Quartile 2, which is the middle, is going to equal the 50th percentile. So they will overlap each other. And quartile 3, I think you can guess, will have the same value as the 75th percentile. So the last thing I want to do here is look at, I don't know if I'm on 5, yep. We had an SAT score last year. I'm not going to say who it is, you might know who it is, that represented the 99th percentile. Can you explain what that means? Okay, what it means is that this score is at or above 99% of the people that took it. And that ends that.